Okay, now let's move on to question number 6. All right, this is a slightly different question, although it still involves translation motion. So let's read the question. A uniform 50 kg crate rests on a horizontal surface for which the coefficient of friction is mu k equals to 0.2. So this is a keyword here that now it involves friction. Now what we want to determine is the acceleration of the crate if a force of 600 Newton is applied at this point here, okay, over here. And also we want to determine whether this force applied will cause the box to slide or tips over. Tips over mean the box will be rotating like that. If you can imagine, if the force applied is too big, too large, the box will not slide, but instead it will tip over. It will be rotating. Okay, so this is what we are going to determine. Okay, so we will start with the free body diagram. I'm gonna erase this first. Okay, now the box will definitely have a weight at the center of gravity. This is a square box, so the center of gravity is exactly in the middle of the box. Alright, now notice that the contact point between the box and the ground is quite large. So we don't know where exactly the normal force is acting. Alright, so the key point here is that if the normal force is acting over here, if an A is over here, then the box will tip over, right? Because you know that if normal force is exactly at the end of the crate, then the box will rotate, will tip over. If the normal force lies somewhere in this region, like this one, or perhaps here, if the normal force is here, then the box will slide. Okay, so this is what we want to determine, where the location of normal force is. All right, so let's erase this first. So assuming that the normal force now is acting somewhere over there. Okay, then we have a 600 Newton force applied. So there are altogether 3 external forces acting on this crate. Now, there are actually 4 forces. The other one is friction force. Okay, we use the symbol of Fr for friction. Friction force is equal to mu times Na, the normal force. Okay, now we move on to the kinetic diagram. So assuming that the box is sliding, there will only be one arrow which is pointing to the right. So the box is not moving up and down, and the box is not rotating, assuming that it will slide. Okay, so we move on with the first equation. Sum of Fx equals to magx. So we have 600 Newton minus 0.2 Na, which comes from the Fr, the friction force, equal to 50 agx. Right? Now we move on to the second equation. Sum of Fy equals to magy. Magy is equal to 0. This one is 0. Okay, so we have the weight, we have Na minus the weight equals to 0. So we have Na is 490.5. Therefore, we have Agx is 10 meter per second square. Okay, we solved the first part. But the question still, does the box slide or tip over? Alright, So how do we determine this? We will use the third equation, that is the moment equation. So in this case, assuming that it is sliding, so the moment will be equal to 0 because there is no rotation. Okay, now when we want to calculate moment, point G is over here, right? So we assume that NA is slightly to the right of point G. So when you want to calculate the moment, you need to multiply NA with the distance x. So this is the distance x that we don't know. So we assume that NA is acting somewhere to the right of point G. Okay, so we will use NA times x for moment of NA, and this is going counterclockwise. So according to this will be positive. The force P going to G will be clockwise, so this one is negative times 0.3, right? Because half of this is 0.5, this is 0.5, so 0.8 minus 0.5, you will get 0.3. And there is another force here, the friction, also going to G in clockwise, so this will also be negative, and this will be multiplied with 0.5. All of this will be equal to 0. Okay, so when you calculate, you will get x is equal to 0.467. What did I mention earlier? I mentioned earlier that if the NA is acting at the end, if NA is here, then the box will tip over. So what is this value here from G? What is this here? This is the length is 0.5 meter. So therefore, since x, the calculated x, is less than 0.5, the box will slide and not tipping over. So that is how we determine whether the box here is going to slide or is going to tip over by applying 600 Newton force to the box. Okay.